University Professor of Computer Science and Associate Chancellor for Partnerships and Innovation at the University of Massachusetts, Amherst. And he's going to be talking today about about softwareization of networking protocols, people, and pedagogy, with the provocative question of, is software eating the world? And without much further ado, Jim, the room is yours.
Okay, great. Well, so thanks for the for the invitation to talk here. This is a talk that's sort of still a work in progress, and it's a lot of navel gazing and looking at belly buttons and sort of thinking about what the future actually looks like. And I gave this talk just a couple of weeks ago when I was visiting IMDEA Networks in Madrid, and Ignacio, I think, was there, and John was there. And I just wanted to put a couple of ideas on the table. And I'd really love to get folks' feedback on this, because this is something that, I've been noodling about. And as a textbook author, I've been thinking about what is it that we should be teaching our students. So that's going to be part of this as well. So the talk basically has three parts, and I'll try to stop along the way. I'm never a big fan of going to a talk where somebody gets up and just talks, and then says, oh, golly, I talked too long. I've only got 2 minutes for discussion at the end. So I'm going to stop along the way. And I'd love to get people's thoughts on this, because for me, this is just sort of, I'm just sort of trying to look into the future and think about how we teach and sort of where networking is heading in the sense that you'll see. So I'm going to share my screen, if that's okay. There we go. My PowerPoint. Okay. Can everybody see that okay? Somebody has to say yes.
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 Yeah.
Okay.
They can see.
Come on, this has got to be better than teaching a course, right? Because sometimes it's hard to get input from students. Okay, so as I said, basically this talk has three parts. I want to talk about PPP, and not the protocol PPP, but protocols, people, and pedagogy in the context of this theme of software eating the world. So you've probably all heard of this sort of very famous phrase by Marc Andreessen, who invented Mosaic and is now golly, we're being recorded, but let me just say he's a very well-to-do venture capitalist, and he thinks in really big terms. And he had an op-ed piece in the Wall Street Journal about software eating the world, and his observation was that a lot of really big companies that came into being in the 2005, say 2015 timeframe really came into being were basically software companies. And so I always like to use, when I teach, I use Netflix as an example all the time, to think about the fact that, what is Netflix? It's really a lot of software that does something. And he made the case also for Amazon and Salesforce and other companies like that. And so that, his premise, and if you haven't read this, it's a 3-minute read, but it's a pretty thoughtful read, is that software is enabling companies to be disruptive, to do things, very, very quickly. And so that's his software is eating the world. So I wanted to start this talk with 3 quotes. This is the first one by Marc Andreessen, that software is eating the world. The next one comes from a networking person. So this is from Nick McEwen, and I'm going to read the quote. And he's looking forward to 2030, and he was talking in particular here about education, that networking students will learn how to program a network top-down as a distributed computing platform. And of course, Nick is really one of the fathers or parents of SDN. I should say, when he was at Stanford, now he's a VP at Intel. And the second sentence here is the one that just absolutely floored me, because he's talking about teaching. He says, protocols will be described in quaint historical terms, okay, in 2030, which is only what, 8 years from now, right? And so that really hit me, right? I've thought, as all of us have, about protocols a lot, and in many ways, our research is about protocols. And you know, somebody like Nick, who I just respect so much, saying, gee, you know, protocols, they're going to be quaint, they're going to be historical. You know, nobody wants to be working on anything that's quaint or historical. And so I will tell you, this quote has now, I mean, I heard it a year and a half ago, and it has sort of been percolating around in my brain, and I've been thinking about why it's true and why it's not true. And in many ways, that's sort of what this talk is about, right? I actually thought about titling this talk, "Are Protocols Dead?" Right? And I want to actually, I've got a slide later on about whether protocols are dead. So we've got a quote from Mark Andreessen, we've got a quote from Nick McEwen, and the last quote is my quote, because it'll sort of show you the quandary that I'm sort of in, and I imagine some of us are in. And so this was some of you may know, the first edition of our textbook came out in 1999. And this phrase, I think I wrote this sentence, was in our first edition, and it's in our current edition, the 8th edition, right? It says protocols are running everywhere in the internet, and consequently, much of this book is about computer network protocols, right? And so that was absolutely true in 1999. I would say it's probably still pretty true now, but you know, in light of Nick's talk, in Nick's quote, and in light of, you know, Mark Andreessen's editorial, I've been thinking, well, you know, okay, I've said that, but what will our textbook look like in 2030, which is only probably 2 editions from now, right? And so these are 3 quotes that maybe you can, you know, let them percolate around in your brain. Software eating the world, protocols in just 8 years from now being talked about in quaint historical terms, and see if that makes you feel good about your work. And then this quote that, you know, comes from our book. Okay, so that's just sort of the preface. That's sort of what has got me thinking about this and why I put this talk together. And again, really happy just to share these ideas with folks here and to get your input and really have this be a conversation. So I want to talk a little bit about protocols and are protocols dead first, and then we'll talk about people and network, a little bit about network management, and then about teaching about pedagogy. Okay, so I probably don't need to do, I wasn't quite sure who was going to be here, but looking at the names, I think on the Zoom screen, I think probably all of you know this already, right? But just to set the context, of course, you know, in our traditional view, we've got you know, a network, and until SDN came along, you know, the notion was, at least if I look at forwarding and routing as 2 examples, that we had routing protocols. They would run, they would be distributed, they would be based on Bell and Ford or Dijkstra's algorithm, and we'd have OSPF or ISIS or BGP or whatever, and those would be used. Those protocols would run, and their computations would be used to craft the local forwarding tables. Okay, and obviously a clear separation between the control and the data plane, and lots of protocols, right? And so, you know, our textbook, it's about protocols, right? A lot of it is about protocols. So, you know, what, 12, 13, 14, 15 years ago, SDN comes along and says, well, you know, another way to think about this management plane, of course, is, okay, open up the routers, but now the computation, the algorithms that are running, there's not actually a routing protocol, there's a routing computation that's done in a remote logically centralized SDN controller, and the forwarding tables are pushed out, say through OpenFlow or something like that, right? So we've got something logically centralized and where you can do flow configuration and management. And you know, there's been a lot of interesting work over the last 5-8 years on what that allows one to do when you've got a logically centralized controller. You can look at configuration and do all sorts of, you know, check for correctness and loop freedom and reachability and other kinds of properties that will, I'll just say a word about in just a second, right? So this is just by way of background. Okay, so it's clear to me, and I'm sure clear to all of you, that this migration away from protocols is already underway. And so here's a picture from the NSDI paper last year about Google's Orion, which takes what they had been doing in their data center for SDN, the Jupyter work, and then what they've been doing in the wide area of the B4 network for, I don't know, that's 7 or 8 years old now, combining both of those and making sort of a unified SDN platform called Orion, right? And so if we think about, if we look at this diagram, I mean, you know, it's sort of a very typical SDN-like diagram now, right? So that you see there's where routing is done, right? There's a routing engine for the intra. So of course, this is just within Google, right? So we're really talking about intra-domain routing, and maybe the IBGP portion of distributing BGP information. It's being used for traffic engineering. And again, you know, this is all being implemented now at the application level on top of the Orion core. You might think about flow control or congestion control, something like that. So there's a flow manager, some of the co-flow scheduling work that, for those of you who are around in the 80s and 90s like me and remember, you know, scheduling in multiprocessor systems, you know, co-flow sort of takes that, but looks at it in sort of a data center a context, but that's looking at collections of flows between groups of machines and their associated semantics that all have a collective objectives, and how to schedule them, right? Where they're going to go and how the flows between them are going to be passed through the network, right? And so that's starting to look like combined routing and congestion control. And then, of course, you know, the management itself is being done in the context of all these pieces communicating through a pub-sub distributed microservice architecture, which is how the Orion pieces talk to each other. So you look at something like this and you say, oh, wow, you know, I always tell my students, you know, routing and congestion control are 2 of the top 5 networking problems that they should learn about as students. And I look at 2 of those and I say, oh, wow, you know, I don't see protocols there. I do see algorithms. I see them implemented in software. I see them running in an logically centralized SDN, but I don't see protocols. And so, and now I want to come back to Nick's comment about protocols being talked about in quaint historic terms. Quaint. That's the word that really got to me. And ask the question, well, will we still need protocols in 2030? So we've seen already for intra-domain routing, we don't need a protocol for that anymore, right? If you sort of adopt the SDN view, maybe we don't need that for a lot of congestion controls. So if some of these, what we might call super core, what used to be core protocols, if we don't need them now, you know, in 2030 and the migration's away, we'll be seeing even less of those. So why do we need protocols? And this is something I'd love to hear people's thoughts on. And let me give you my thinking about, you know, well, is Nick right? Well, you know, he's right in some ways and he's not in others, I think. But so I do think there's a need for protocols. But this kind of thinking makes you think about, well, okay, well, why do we need protocols, right? And so I want to put forth a couple of cases where I think we will still see protocols in 2030. So for internetworking between different organizations that have separate control planes, right? Unless there's some uber logically centralized control plane overseeing a lot of different organizations, which probably won't happen for a lot of business business reasons. If you think about now, you know, the BGP4, the eBGP part of that, you think about there are mobile packet cores that are now running in different wireless carriers, 4G, 5G carriers, for example. There's going to be the need to inter-network between those control planes, right? And so I see protocols not quite being dead yet in 2030 because of this need for internetworking between organizations. So now I'm thinking, oh, okay, a key aspect of why we even have protocols is we need to internetwork between organizations. It's not so much anymore internetworking or combining different devices, because devices within an organization can be managed through SDN techniques. But when you go across organizations, you still need protocols. Okay, so I would say protocols is part of that. Of course, we're going to have application level protocols, because in some sense, me using HTTP, I'm in my home network here, and I'm going through, I'm going to some other organization's server, right? So at the application level, I'll say we're still crossing multiple organizations. And then I think there's going to be a need, again, this is because you've got two entities coming together that are unknown to each other, that for things like identity management, when you initially connect to a network to do trust establishment, to establish what your capabilities are in the network that you're attaching to, that we'll still need protocols for that, because you've got these two entities coming together, they don't know each other. And so there'll be a protocol for, establishing trust, establishing capabilities. So I want to put this forward as three areas, and I don't think it's necessarily, it's not exhaustive, but this is sort of one of my takes as to why we're going to still need protocols, but maybe not in sort of the core part of the network or of the network protocol stack that we thought about. So I'm going to stop in just a second, and I'd love to get people's thoughts on this. I want to just put this slide up. This is, I think what happens as you get older is you sort of think about evolution, where things have been and where they're going. And so I just wanted to put this picture up because I think it's sort of, it's something I'd also been thinking about for a while, and sort of resonates with this notion of where protocols are. So, and I mean, we could talk about this. This is sort of a little bit orthogonal, but that, up until 2000, we were still, as a research community, I think, focused on the artifact of the network and on performance. Not everybody, obviously, but that was sort of a main piece of it. And here's sort of my own personal heat map of where I sort of saw a lot of activities leading up to, the 2000 timeframe, the transport layer, the network layer, and less so at the application layer at that point in time, and at the link layer from 2000 to 2008, when 2007, 8, iPhone comes out, a bunch of things happen then, SDN happens then. One can sort of trace the more cloud computing sort of at scale really starts then. But in that 2008 timeframe, distributed applications, mobility, security. In the 2008 to 2020, mobility, the rise of data centers that we've seen, issues of security and privacy, and management now, and configuration, and this sort of ties in with SDN. When I was studying networking, I always thought that this third dimension where we had sort of the management and control plane, that wasn't the interesting part of it. And now I think that's probably the most interesting part of that, right? And so this notion of management and configuration and, protocols, and moving away from protocols in many cases, and putting the management and configuration sort of into SDN, logically centralize the additional things you can do there, where I see things sort of heading in the current decade. Okay, so before I talk about people in pedagogy, it's always good to stop, and I'd love for somebody to, I'd love for comments, I'd love for questions. Let me stop sharing so we can see each other. Ignacio, you're the only person whose video I can actually see. And, oh, Frank Kelly, I'd love to see your video. Well, sorry, we should never call people out personally and say, Richard, okay, great. But I'd love to hear folks' comments on that. Do you think, are there other sort of classes where you think protocols are still going to be needed? Do you think that I'm completely off base with saying, I don't know, routing, congestion control, sort of on their way out?
So I guess what would you say about all these ad hoc protocols of people putting things into protobufs and communicating across different parts? It sounds like even if protocols as such might disappear when a large organization or everything is within a data center, there's still communication going on, and different parts need to agree on how exactly to communicate, and even if it's just a protobuf.
Well, but let me push back on that a little bit, right? Imagine all the devices in an organization, right? So you minimally need a protocol for that device to communicate with a logically centralized control plane, right? But all the configuration, I guess I wonder, right? So even my device, right? So if comes the day, in some sense, the zero conf, it's like everybody's goal, right? You attach and everything is configured for you the way you want it, right? And there aren't all these, individual zero conf protocols that it's all managed for you locally. Your device is part of the organization that you're in. And those kinds of protocols can just sort of go away because the configuration management, the, how the devices are communicating with each other, the routing, the flow control, the congestion control, it could just all be managed centrally. Or maybe we should ask ourselves, what can't be managed centrally?
I guess that then the point is what cannot be managed centrally. And I think that goes back to your point of all those things that are owned by different people. So it's quite funny that from what you're saying, if I read it right, you're saying we need protocols for deal with a not networking part of the thing. The fact that two things are owned by two different economic entities means that we have to manage that in a way that cannot be centralized because, well, first they would have to agree.
Right. And, I think that's exactly right. I think that's sort of the bottom line, that when you're not in the same organization, you don't have that trust. So you're not going to sort of give over your management, your configuration, your performance tuning, things like that to somebody who's not in your organization, right? I think it sort of comes down to that. If that's true, then that says the only time you need protocols are when you're crossing organizational boundaries or joining an organization.
I was just going to say, I think one thing that is not clear is
Hey, Hamid.
Hi, how are you doing? I was just going to say, I think one thing which is actually not clear is what do you mean by protocol? Do you mean a set of standards which have gone through an independent standardization agency, or do you mean something that I design as Google, I implement it, and I push it through so hard that you don't have a choice but accepting anyway? So I think our definition of protocol is rapidly changing as well, especially in the web and applications. Okay. And actually, yeah, Colin has mentioned APIs. That's another example, right? I put something up, I expose a bunch of APIs to you, take it or leave it.
Okay. So let me tease apart a couple of things you said. And I'll remind you, we're being recorded, and somebody said Google knows everything we do. So, but that's okay. I did the canonical mistake that we all make, right? I used a term and I didn't define what I meant by a protocol. So I wouldn't call an API a protocol, right? I'm thinking about protocols about two entities that need to exchange messages to do what they need to do, right? So I guess that's my sort of off the top of my head definition of a protocol. And so you do need a protocol, for instance, maybe use OpenFlow to communicate between your device and get configurations from the SDN controller. So yes, there's a protocol for that, but I'm not sure I would call an API a protocol. Absolutely, we need APIs, right? Well, where do we need APIs? I guess you need APIs when you're doing the internetworking, or you want to cross, or you need public APIs when you're crossing these kinds of trust boundaries and you've got different implementations. But Hamed, that the issue of somebody pushes so hard that you have no idea, no alternative but to say yes, sure, that happens in standards bodies all the times, I think, not just with say QUIC or something like that, but in all kinds of standards bodies that happens. I think that's an orthogonal question.
Thanks.
Okay.
I think Richard wants to say something.
Yeah, so I'm going to just read John's comment. We need protocols to install new configurations. So absolutely, given high availability requirements, these have to work with replicated state machines, causal ordering, ultra low latency, and are therefore about as complex as any protocol yet today. I would agree with that 100%, right? And so that's sort of the almost the plumbing piece of the configuration management, the reliability aspects of being able to, if you're giving away all your autonomy because you as a device are going to be configured externally by this entity that you've got this protocol with, that protocol for doing that kind of the replicated state, the causal ordering, those kinds of things, that's got to be bulletproof, and that's absolutely complex.
I think that Richard had a question.
Yeah.
Yeah, well, actually, firstly, I want to say it's lovely to see you teaching with those slides, because for years I've taught with those slides. So it's nice to see the originator of them teaching them. I'm having a bit of a failure of imagination here, actually, because I'm thinking about things like I arrive somewhere, I wave my mobile phone or laptop in the air, and I want to connect to the network. I'm a new ISP, I want to connect to a bunch of others. I'm failing to see how that works without a protocol.
Right, but I think what you just mentioned was one of my cases where I agree we need protocols, right? And so, one of the things that I love teaching about 4G, 5G with students is that because you've got SIM cards, you've got a very strong notion of identity of who you are, right? And so when I get off a plane in Paris or London or wherever, there's a protocol that has to happen because my device, which is unknown to whichever network I'm trying to connect with, has to establish that trust relationship, right? And then then there's got to be signaling back to my home network to say, oh, Jim has paid his bills and he's allowed to connect to any network, and there'll be some economic settlement. But that's all about the attachment. So I agree with you 100%. That's all about the attachment and sort of getting onto the network or attaching your network into another network at sort of a BGP level. Then I think that, that's, I guess, the case I'm trying to make. I think those are cases where we're going to need protocols.
You mentioned 5G, and those people, they're slightly tying themselves at knots at the moment, aren't they? Because they didn't develop a standard protocol, and now you can't mix between the kits, and so they're having to go back and go, oh well, we'll develop ORAN, their version of SDN to be a standardized protocol.
Well, but
it seems like they didn't develop a protocol, and now they're a bit stuck.
So I think it would be, it's pretty interesting actually to take 3GPP as an example, right? And to think about the 3GPP components and the protocols that sort of run internally inside a RAN, for example, right? And there's no a priori reason why those have to be protocols, unless you sort of believe in, sort of real disaggregation and, well, this, the home location registers being, this is one box and here's another box, and they're speaking protocols to each other. They could also be logically configured the same way that, routers are logically configured, right? Through a control plane. And so the knots that people are tying themselves into about what the internal structure of an ORAN is, or a RAN is, to me, it's not clear. You could build that using protocols, but you don't have to build that using protocols. I guess that's what I wanted to say.
So Jim, I guess what I'm hearing you say is, and also when I look at different protocols, like whether it's routing protocol or whether it's congestion control, there's state in more than one place in the two endpoints of a TCP flow, or
yes.
And if you have a logically centralized way of doing networking, then you're saying, apart from just doing the configuration alone, There's really, and setting up the trust and so forth. There's really no need to actually have protocols to communicate parts of that state from one entity to another.
That's a great observation. I hadn't actually thought about that in terms of state management, but you're right in the sense that when you have protocols, a lot of the reason that you're doing that is because you've got distributed state and you don't have any notion of what, you don't have any Uber overview of what the a single logically centralized state view is. It's distributed. Yeah. Yeah. Sorry, I'm just going to write that down. So think about state. Okay.
And John is adding security to the list of things where you might need protocols.
Yeah. Okay. So I want to get a couple of other things out on the table, but this has been great. I'm going to share my screen again. So Richard, you said talking without slides. Honestly, I'm genetically incapable at this point to speak without slides. So I'm going to have to go back and rely on my slides again. Okay. Okay, so these next two things on people and pedagogy, I think the people part here is pretty straightforward, and I just sort of want to talk about what I see as sort of logical consequences of sort of the protocol sort of going, some of the protocols anyway, going away and taking people out of the network management loop. Apropos our earlier discussion about the importance of the depth of the management plane. Okay, and so there has been a lot of interest on high-level intent. So I have to tell you, when people started talking about intent-based management, I flashed back to a DARPA study group or something that I was on in the 1990s, and people were talking about where their research was happening, and I was saying, oh, I'm doing stuff in congestion control and multimedia and things like that at the time, and so I guess I'm a layer 4 person, and somebody said, well, I'm a layer 13 person, that they were a layer 13 person, right? And which just totally floored me, and I said, well, what does that mean? And they're like, well, I'm all about, we should be telling networks what we want to do, and then they should just go and do that. So here it is 15 or 20 years later, and now I understand what that person meant. Anyway, so intent-based networking, the idea here is at a high level, and you're starting to see more and more of this in practice, I think even among our students, that we specify the management and the design changes by where we want the state of the network to be rather than how, and that the software, apropos of software sort of eating the world, does all of these things for us. And so we sort of got two different timescales here, right? We've got the high-level intent timescale, where this is what I want the behaviors to be, and then how we actually get from those, that happens in almost a compiled way, right? That from that high-level intent, then there's sort of these lower-level intermediate intents, and the configuration changes then that are needed to realize that intent are sort of compiled in, and we've got sort of the equivalent of a runtime that accompanies our operating system to sort of make sure that the intent at the high level is being satisfied by these sub-level goals and the configurations that are in place to realize each of these individual goals. And so this is a paper by Nate Foster that I found actually a pretty interesting read. And once you start putting all these things in software, this notion of, again, the automated correctness and consistency checking, I mean, that's, again, in the context of SDN, that's something that people have been doing for a number of years now. So it's clear to me then that with SDN, with protocols, at least some protocols, algorithms behind protocols, rather, I should say, now happening in an SDN context rather than a protocol context, that I always think when we teach students, well, what kind of jobs, for students who are going to go out and get jobs in the field, what kind of things are they going to do? And, when you think about network management and people who run and operate networks for a living, it's very clear that this notion of, the way I configure my devices is I SSH in and I type in my CLI or whatever to, whatever router or switch or whatever box I'm connecting to, right? And this network management then becomes, it's embedded inside the software. It's what's compiled in, and that sort of then becomes the secret sauce then that's going to distinguish one carrier, one network provider from another. There's been with things like P4, for example, there's been a lot of interest, for example, in that lower level control loop. Remember, there's the high level intent, but then let me go back to that. Sort of down here at the bottom, having this notion of fine-grained telemetry. So taking measurements, matter of fact, dynamically deciding where I need to take measurements, feeding that back to the SDN controller and say, hey, is that the kind of thing that that's consistent with what these intermediate intents actually are, right? And so that's been called a, actually, I wanted to call people's attention. This is a paper. It's only, I looked at it yesterday. It's only got like 7 or 8 citations to it, which when I read this paper, it pretty much blew me away because it's talking about, they call it a verification transverse, right? And so what they were talking about in this work, so this work came out of Bell Laboratories, or Alcatel, I guess I should say, that what you would do, they were interested in SLAs and sort of runtime performance monitoring, right? And then, so the idea is you'd have these SLAs, you could specify these in extended temporal logics, that then what you would do is you would compile, again, so this is then in software, the runtime P4 in-network telemetry monitors that would then be deployed. They would be doing measurements then, they would be feeding back, and you could check the measurements that you're getting against the SLAs, and then if SLAs are violated in that particular case, then you would take some kind of corrective action there. And so this is, so here's the paper on runtime performance monitoring, verification, and healing. So apropos of taking people out of the loop, this notion of a verification transverse, all of this is actually automated, and what you specify at a high level is just this SLA intent. Okay. So let me spend 5 minutes on pedagogy, and then we can open it up for more questions. And so this has to do with this question of teaching. So I know most of us here do some form of teaching, and my question, having written an introductory textbook, is what kind of things do I want to, given that protocols won't be, or all protocols won't be necessarily quaint or just discussed in historical terms in section 1.9, where you talk about history, right? But that they're still in the core of the book. What goes into an introductory network course? What do you think you're going to be teaching in 2030? So, here's a picture of the first edition of our textbook. I had a quote from that, and in the late 1990s, a top-down approach was novel in computer networking. It wasn't in graphics. So John Crocroft told me about a graphics textbook. Operating system textbooks went through this transformation in the late 80s and into the 90s, from going from bottom up to sort of more top down. And this notion of top down, in my mind, reflects the computer science view of the importance of abstractions and APIs we mentioned before, and a lot of comfort in just building on top of those, rather than sort of having to understand everything from the bottom up, which is my EE colleagues tend to sometimes think a little bit more that way, right? So I would say networking is a lot of people now teach it and think about it top down. And I've been thinking about this question of protocols and if there's a death of protocols, what does that mean? I'll say that it was clear to me in 2012 and 13 that I guess the 6th edition of our book was out, and it still had a very traditional network layer. And we talked about Dijkstra and Bellman Ford and ISIS and OSPF and BGP. It was very clear to me that I was starting to feel bad that I was graduating students who took our undergraduate introductory networking course. And if they went and interviewed, I don't know, at Cisco or Juniper, and somebody said, well, what do you know about SDN? This is now 2012, 13. They would have said, oh, my instructor never told me about SDN, right? And so in so that got me started thinking about trying to restructure our textbook so that there was a clear separation between the control and the data plane, which I think, had already been well underway in networking for quite a while, but making that very explicit by taking what was one chapter before and dividing it into 2 chapters. So there's a data plane chapter. So this was in the 2015 version of our book, a data plane chapter now, where we focused on match plus action, abstraction, and generalized forwarding and open flow, and think about destination-based forwarding that routers have traditionally done is just a special case of that. And then a control plane chapter now, where we say, well, there are routing algorithms, and here's how you can compute shortest, least cost paths in a distributed, centralized way. And you can implement them in a routing protocol, or you can implement them in SDN, and especially in the latter case, the importance of data models and introducing netconf and Yang. So, sort of trying to keep up with where networking was headed. We try to keep our textbook up to date about that. And so again, I'm trying to think, okay, I don't believe protocols are going to be dead, but I think they're becoming, certainly in routing, for example, they're becoming less and less important, except at the BGP inter-domain level. So, I think, so we're moving our emphasis in what we teach will probably move a little bit away from distributed protocols and more towards algorithms, at least for some of this. And then how you implement that algorithm, it's either centrally in an SDN context or by a protocol. And we'll just teach protocols, at least in some of the core, as ways of implementing algorithms. And I think all of this just speaks to the importance of distributed systems coming to the forefront for scale, for robustness. I mean, some of the things that folks have already talked about already. And the identity management, which is honestly something that, in an internet context doesn't sort of really exist, I might argue, but in a mobile context, especially, 4G, 5G, and with SIM cards and things like that, you do have an identity and what that means. So these are just some of my thoughts. My co-author, Keith Ross, and I actually met in France earlier this month to sort of plan out what we were going to do in the 9th edition, and sort of these were some of the things that we were talking about. Okay, I've got some closing thoughts, but I think I'm just going to sort of skip over these. I'll just say thank you again, and we still have plenty of time for conversation here, so I'm going to stop sharing my screen again and see if folks would like to, I don't know, comments on what we teach, how we teach, humans in the loop, humans not in the loop, those kinds of things. That's what we covered in that sort of second half here.
Thanks again, Jim. Questions from the floor, comments from the floor?
I'd be interested. What do you think you're going to be teaching? What do you think you're going to be teaching differently in 2030 than what you're teaching now, if you're teaching an introductory networking course?
I guess there's lots of things like formal verification, which may not be in many syllabuses, which are becoming programming and programming languages and formal verification and things like that are becoming much more central than they were before.
Right, right, and you know that Alcatel, if you enjoy formal verification, like I do, actually I tried to write my PhD thesis in that a long time ago and decided it wasn't going to go anywhere, so I did something different. But it's been a lifelong love, and if you're interested in that, you'd really like that Bell Labs paper.
The whole goal is, the whole software-defined networking goal is to reduce the amount of code any human writes, and the whole goal of verification is to reduce the amount of wrong code anything writes. Right. And the net effect of this is we'll be teaching very, very little. If you can reduce, the intent is make it so, internet required, and then everything else is derived from that. It's a bit like the 4-vector form of Maxwell's equations, right? You can derive all of the other stuff from that you could ever want, is relativistic invariant and so on. And, there are mathematical style systems that can do that. And then what do we teach? Well, maybe we could just switch over to arts, and like Amherst, actually, you've got arts, right? You've got proper, you've got liberal arts and stuff. We don't have that in that model. We need to switch to that as soon as possible.
Oh, wow. Yeah, I mean, I went to a small liberal arts institution. I'm a huge fan of that. I'm also, well, this is really getting afar. In the US, we have this debate in computer science departments between people who came up through an engineering curriculum and those who came up through a liberal arts or a science curriculum like I did. And generally I'm going to overgeneralize, so I apologize here, but an engine, a lot of times in my department, the engineers were like, oh, how can you not require this and not require this and not require this? And the liberal arts view is, well, you let people sort of pick and choose, and you try to define a minimalist core and then let people's interests sort of flow from there. Yeah.
So, the liberal arts tradition would allow people to make judgments that would be, okay, they're value judgments, but the idea that Alexa and Siri should speak to you in the voice of a dead relative, it would occur to people this is probably a really bad idea. Whereas, the pure science and engineer would say, hey, this is really cool. I think we can build a GAN that will train a deep learning system to speak with the voice of dead people, and then you can pick which one you want, and it will react to your emotions on your face by doing face, emotion detection stuff, right? So this is why we need to get away from. But I mean, I'm not completely joking. I mean, that one of the goals is, that we have millions of lines of code out there written by people, and that half of the problems are caused, more than half of the problem. Many of the problems of security is, the large number of vulnerabilities occur because there are too many flawed pieces of code written by people. And if you take a generative approach to the system from high-level specifications, you even get rid of half the verification problem. The systems are correct by design, but you still need to get what are the requirements, and that takes some clever thinking.
Right, and I'll take that actually even one step further, because you're talking about sort of the static compilation, and if you think about runtime, one of there was a paper. How sometimes papers stick in your brain for decades, right? So there was a paper, again from Bell Labs, but from a different group of people in the early 1990s, that was looking at formal specification methods, and then saying, gee, if I have a partial view into messages that are being, it was in the protocol context, about messages going back and forth, are the messages that I'm seeing consistent with a correct implementation and configuration of that protocol, right? And so you're taking it not just from the static checking before you do the installation, but then sort of at runtime you're doing, and then there's all these interesting questions about, well, you've only got partial views, you're not going to see everything, or where you should look to see things if you suspect there are problems, trying to tie what you're observing to those formal specifications.
Okay, so you want a digital twin of the internet?
I'm not sure. I'm not at all sure about that. Because I'm never sure a digital twin is any better than the real thing, right? Or it's got all the bugs of the real thing and then some, right? But
yeah, there's this very small, tiny story by Jorge Luis Borges where there's this kingdom where they make a map and they find that the map is useful. They make a more high resolution map and higher resolution map and so forth, until the whole map covers the whole kingdom, and then they have to tear it all apart. It's going to be something like that, I guess. Any other questions, comments from anyone? Richard?
Let me,
Yeah,
if you don't mind, let me read a comment from Mahesh Marina here, because I know some people have mentioned they don't have access to a microphone or a camera. I mean, they've chatted with me about that. So to me, interaction among entities, distributed system is dependent on protocols. Okay, so with SDN, we move towards centralized control and management, but not away from a distributed system. So the need for protocols is not reduced. Okay, so I want to comment on that. What has happened is that the processing / computation in the network has been re-architected towards more centralized computation. Absolutely. And has potentially simplified protocols like OpenFlow. So I think that my only pushback to that is, again, coming back to routing, there is a reduced need, right? Because I think I look at OSPF and ISIS as simply one way of implementing a routing algorithm, right? Either you implement it centrally and then use OpenFlow to distribute the results of the forwarding tables out, or you implement it in a protocol, right? And so if you have it's sort of the best example of, I think, if you've got a logically centralized control plane, then that's a protocol you just sort of don't need. So I think there are less protocols. So I would disagree with the statement, the need for protocols is not reduced. It is reduced. It doesn't go away, right? So as you said, you need protocols like OpenFlow minimally in that context to distribute distribute the forwarding tables. Oh, I don't know, Mahesh, sorry. I didn't realize you had audio and video.
I think this is just a matter of perspective, I guess. To me, OpenFlow is still a protocol. It is a very simple protocol.
Right.
In that sense, that's sort of the result of how the computation has been re-architected. And in general, the points that you said earlier about needing protocols when you're communicating between independently managed entities, I think that I agree. This includes even the end devices. But within the network or within a domain, the nature of protocols has changed from being more open to more proprietary, and also becoming simpler because of the way the computation is restructured. Like routing computation, it is restructured to be more centralized. So which means that it becomes more simpler in terms of the protocol, like HTTP request reply kind of protocols, as opposed to having a distance vector type of computation, which is completely distributed.
Right, but there's neither a distance vector nor a Dijkstra calculation that goes on out in the routers anymore, right? So that protocol, so in some sense you're right in that, so instead of a link state broadcast, for example, now that information is being gathered, that and lots of other information is being gathered centrally through OpenFlow in a centralized controller, right? And so maybe I should count that gathering of link state information as part of a routing protocol, but I see what you're saying. Okay. So anyway, thanks for the comments. Thanks for the invitation just to sit here and have a conversation with folks. I've written a number of good things down here that I want to think about. I don't know, Nishant, you want to make an oral advertisement?
Sure, why not? Well, I guess we're going to have this workshop at Surrey mid-July 12th and 13th. We've got people talking about Starlink-like networks, basically. So blue sky thinking about computer networks in space. And well, I guess beyond just Starlink-type networks, we've got NASA talking about LunaNet, which is their upcoming network for their permanent base, the Artemis base that they're going to think about in the moon. So if you like that kind of thing, then join us either online or in person. In person, there's good food to be had, but online is probably more convenient. Oh, and drinks as well.
So when protocols die on the earth, protocols appear on the sky.
Exactly.
I think that's a brilliant end of the seminar. Thank you very much, Kim, Jim, for joining us. It was a great talk again.
Great. Thanks a lot for the invitation and great to see you all.
Thanks, Jim. Bye.
Bye, everybody.